So welcome from basically all around the world to our PLS 2022 Prelude session number 3 on performance state-of-the-art mediation, moderation and conditional mediation analysis in partially square structural equation modeling, PLS-SEM. We are going to see an introduction, recommendations, and examples. Before I'm going to introduce our presenters, let me share some words about this event. We planned the PLS 2020 conference to take place in Beijing, but for the reasons we all know, we had to postpone this conference until late October 2022, and we are quite confident that we are capable to run this core conference on PLS-SEM, methodological advances, applications in Beijing in person, and to entertain ourselves until October 2022. We thought it might be a good idea to start these series of Prelude events. And we started with the Prelude session 1 and 2, and now we are entering in the third Prelude session. If you'd like to get information about the first 2 sessions, please visit our webpage, www.pls2020.org. And under Prelude events, you will find the previous sessions. And also on the PLS 2022 Facebook webpage, you can access the videos of the previous sessions. Also, you will find them on YouTube. We put them into the SmartPLS YouTube channel. And in the SmartPLS YouTube channel, you can also find the previous Prelude sessions. We are recording this session, and this video will also be later on available. So if you like the session and like to let colleagues and friends know, if you like to learn something more about mediation, moderation, and conditional mediation in PLS-SEM, take a look at the video. Then you can share the links and this information later on, if you like. So it's our pleasure and honor to welcome 4 very renowned persons in the PLS-SEM community and top experts on the topic. We have to start with Christian Nitzl from the University of the German Military Forces. And Christian Nitzl is located in Munich, and he has been more or less from the very beginning of his academic career infected by the PLS-SEM virus, did a lot of core research on the topic, and continuously advances with his publications from a methodological point of view and from an applications perspective. His most cited papers are Mediation Analysis in Partially Scarce Path Modeling, published in Industrial Management and Data Systems, and he also has a well-cited paper on assessing measurement model quality in PLS-SEM using confirmatory composite analysis. Then the next presenter will be José Roldán from the University of Sevilla. And José Roldán is a professor of management at this university, and together with Gabi, probably the most renowned persons on PLS-SEM in Spain, in Europe, and around the globe. And they started very early to run research seminar series, having, for example, Win Chin and Joe Hare and Sevilla with them. And they continuously run PLS courses in Spanish with their university, and have great publications on the topic, also methodology-wise and applications-wise. So José Luis' most cited papers are variance-based structural equation modeling, guidelines for using partially squares in information systems research, and the other paper co-authored by Christian Nitzl and Gabi Cepeda is mediation analysis in partial least squares path modeling, helping researchers discuss more sophisticated models published in industrial management and data analysis. Then we will welcome as the third presenter, Gabriel Cepeda, also with the University of Sevilla, and he's a professor of management and sports management. And yeah, his publications, which are particularly well cited, are on dynamic capabilities and operational capabilities, a knowledge management perspective, and the other paper I already mentioned, mediation analysis and PLS-SEM, but also applying maximum likelihood and PLS on different sample sizes, studies on surf call model and employee behavior, which was published in the handbook of partial least squares. And finally, we have Jacky with us. And Jacky is with the University of Putra, Malaysia. And Jacky is particularly well known in the Asian PLS-SEM community, co-organizing the annual SASEM conference in Malaysia, which had a huge impact in the region over the past years. We started, they started to run it in presence, which was a great event. I had the opportunity and the pleasure to visit Malaysia and this conference, and the last two have been virtually conducted, but also have been a great success. And Jacky also publishes in the PLS-SEM area. And he looks on the applications, on the use of the techniques on certain topics, but also tries to give guidelines and publishes on the use of software applications. His most cited publication is a textbook on partial least squares, structurally equation modeling using SmartPLS 3, an updated guide and practical guide to statistical analysis. And he also had a high impact paper on predictive modeling, SEM guidelines for users to predict, that was published in the Journal of Marketing. So with these well-known experts in place, we are now going into the presentation. And I will hand the screen and the microphone to Christian Nitzl, who is starting to bring us into the topic on mediation, moderation, and conditional process analysis in PLS-SEM. For all the others, while we are enjoying this presentation, I would kindly ask to mute yourself, that we don't have some disturbing noises in the background. And if you have a question, I would suggest that you please use the chat, because we have our experts here, and these experts who are not presenting, they're happy to take care of your questions in the chat while the presenter can concentrate on the presentation, and thereby we will probably make this session most enjoyable for all of us. So for now, that's all about from my side, and Christian Nitzl, the floor is yours.
Give me a second, I will share my screen, and I hope you can see my screen now. So switch to the presentation mode. And now, first of all, I have to say thank you for this friendly invitation. It's always nice to hear from someone else what I have done. But someone forgot so fast what papers one have written and so, and it's nice to hear from that. And this was very fantastic to see our mediation paper become so widespread and acknowledged from the community. And looking here at the community, it's really great to see from all over the world the people, or they don't see, but know that you're here. And this is really great. It's really a compliment, I have to say, that you're joining today. And I will try to give a general introduction in the topic of mediation, moderation, and why it is important in the end of conditional mediation. At the beginning, I will start with a statement by Viktor Frankl. Maybe one or the other will know him, but he was a Jewish a researcher, a psychologist, and he survived the Holocaust in Germany. And it's very interesting what he's saying in this statement. And he said here, between the stimulus and the response, there's a space, and that space is our power to choose our response. In our response lies our growth and our freedom. And why I choose this statement, because it makes somewhat clear why is looking at the mediation process, why it is important to looking at this between a stimulus and a response. And there's something happened between a mechanism, a process, and this may make research fantastic to look between the two things, because why it is important, and this is the question of why also, and because there is our space to change something. And we want to know how something is working between the stimulus and the response and how we can change that. And therefore, I think this is a good statement at the beginning to see why it is important to look at mediation, moderation, because we're looking in the box. And here I bring with you an example from my new research area. And often we heard about artificial intelligence or the neuronal network. And this kind of research is very interesting when you're looking only in prediction. Also that means when you want to predict something with the best performance to predict something, you should use a neuronal network. But a neuronal network do not answer the question how it comes to this point. You put something, you see it on the left in the box, and something is coming out of the box, a good prediction, and how the algorithm is working, and is like a black box. We know how the algorithm is work, but they're changing so a lot, and they optimize the learning in this algorithm that afterward, when we have trained such a model, we cannot look any longer and understand what is happening. I know there is some work on that, how you can explain this algorithm, but in the end, it stays a black box. And when we say, okay, I have said this is for my new research area, you see on the one side the crisis, on the left side the input layer. And sometimes the situation of a country is very similar. They have inflation rate, or they have the same kind of resources, or the same kind of geographical location, or another important stuff is the climate change and so on. But in some countries, it comes to a crisis like a civil war, and in another country not. And the question is now, why is it? Also why it comes to these differences in, even you have the same conditions or the same situations, why in some countries they are followed by a crisis or not. And one way is to look, as I mentioned, in the black box. And what you need for open the black box is beside a good algorithm like PLS, is a good theory to explain it. And one kind of theory that is useful to explain these differences is the institutional theory. Also that they put some factors from the institutional theory in the middle, and to explain how it comes to crisis, and what could be some factors that mitigated this crisis. For example, in the middle, the separation of powers, or the property rights, or the human rights, or women rights, or the diplomatic relationships, so that have your good military background there. And this explains somewhat the mechanism why some context factors or stimulus can be handled by a country, by and do hinder that it comes to a crisis. And let's make it very interesting. That is when I come back to the citation from Viktor Frankl, that is our space to make the difference. That we can change in a certain way. We do not can change often the stimulus or the context, but we can change that lies between that stimulus and the response. The institution, we can work on institution that we have a separation of powers and freedom stuff, and so that is the space where we can working on as a nation, as a country, and as or the politicals. And that brings me to another point. After I have given a general example, I will give a general statement why it is good to work with structure equation models, why it is helpful to work with them, what can you do with that. When you're looking here, you have some independent variable and dependent variable. This is the situation what you have typical in a regression analysis. And you can easily include it in the regression analysis a moderator variable that you can handle very easy also in a regression, but it becomes not so easy to handle it, but you can do it when you include a mediation variable. That means a moderator is influencing the strengths of a relationship, and a mediation is is mediating a relationship between the independent variable and the dependent variable. Okay, and when you have now a regression analysis in a mediation relationship, you have to estimate at least 2 regression equations. And as you see here, this is quite easy. In a structure equation model, you don't have to estimate different equations, but you have all in a single model. But what happens when you have a more complicated model? You can easily include in a PLS model a further dependent variable. Or if you like, you can include more further variables. And it becomes more tricky. This is reflecting that you measure the variables with, you can directly measure a variable, but often you have the case that you have a latent variable that means you can't measure the variable directly, so you have to measure it indirectly with different items. And in this case, a regression analysis would be very, how would I say that? It would be very difficult to handle that. But with a structure equation model, I would say that it's quite easy to estimate such a model. And therefore, that's especially for mediation moderation, it's really useful to use a structure equation model, especially because such a model become very easily complicated. That means that you can overlook certain effects. I will give you an example for that. When you're looking at if you can see my cursor, this independent variable influencing the dependent variable 1. But this variable is mediated by another variable, say for example, as a full mediation. Then the independent variable, this one wouldn't have no influence directly, but he would have, the variable would have an indirect influence over this past connections. And when you don't look at the mediation, this would mean that you would interpret this variable has no influence on the dependent, even it has, but over other variable. That in short, I think you would hear much more about these relationships, but you see when you have such a model that it's quite easy to overlook some effects when you do not draw into consideration moderator or mediation variables. Now I come to the next slide. That I think I have already said, therefore I'm switching to that one. Now I will start with a very interesting paper by Baron Kenny that was written in 1986. when you're citing today this paper and using that method they invented here in this paper 1986, someone would say it's outdated. Even so, I want to start with that paper because I think it's a good starting point to discussing moderator or mediator variables, because for for reasons that they make it very good understandable what's mediator or the moderator are. And very interesting, this paper, and that you should keep in mind, this paper from 1986 is according Google Scholar, it's cited more than 100,000 times. Means that it's more cited than Albert Einstein or the Sigmund Freud. It's very interesting. I don't think mediation is so important than Albert Einstein, but what it's illustrated is that how important is mediation, moderation for the research today and still growing. And I brought with you here a statement by Kenny by a follow-up paper, Reflection on Mediation. And here the white, some very interesting, some history of the paper, very interesting statement. We first sent the article to American psychologists where it was rejected because the reviewers thought what we were saying was known to everyone. We got similar reviews and rejection when we first submitted the article to the Journal of Personality and Social Psychology. Harry Rice later became editor of the journal. We resubmitted the article telling him that the article had been previously rejected, but we wanted another chance. Rice really liked the article, and against the advice of some of his reviewers, he published the article. History has certainly vindicated him, as the article has become the most cited article ever in the journal. And that, I think, it's very interesting, and I think most of us here in the webinar have some similar experience to sending. Really, we have a good idea and think we want to publish it, and they asked first thing what happens is we get a rejection. We send it to another journal, then we get another rejection. And it's very interesting that even such paper that becomes so often cited in the community even got so often a rejection. And I hope this encouraged you to stay with your research and working at it, even you get some rejection on your research. And now I will come to my last slide. And one last reason why you should use PLS-SEM for mediation, moderation analysis. Even though Baron Kenny's stepwise approach is a good starting point to understand it, but when you analyze your mediation or moderation, PLS-SEM is very useful because they match more to the nature of mediation and moderation, because they simultaneously estimation, and finally you can directly, and that you can't do that in regression, you can directly integrate latent variables in your estimations. Now this was it for my part, and I will hand over to José. And
thank you very much, Christian. I'm going to share my screen. I hope you can see. Well, thank you, Christian, and good evening, Asia and Oceania. Good morning, America and Europe. Well, I'm José Luis Roldán from the Universidad of Sevilla in Spain, and next we are going to start the session dedicated to modeling mediation effect in PLS-SEM. Okay, so let's go. Let's start by explaining the science of mediation. A mediation model describes how or by what means an independent variable X affects a dependent variable Y through one or more potential intervening variables or mediators. In this respect, an indirect effect, also called a mediating effect or mediation, occurs when an independent variable X impacts a third variable M or mediator, which influences the dependent variable Y. Here you are. Oh. Here. And the integrating effect is described by the mathematical expression A times B. Well, we must acknowledge that the mediation effect has caught the interest of academics from various fields, including business, management, psychology, and education. In recent years, the number of studies referring mediators has risen considerably. For example, in this graphic, you can see the growing number of tourism and hospitality studies relating to mediation models. The research's primary objective in mediation analysis is the causal explanation. Mediation studies seek to understand how and why an independent variable impacts a dependent variable via one or more intervening variables. In this regard, the theoretical foundation for mediating relationships should be carefully considered, since researchers seek to explain the causal process behind the link between two variables. That's why a mediation effect should be hypothesized with theoretical and empirical support. On the other hand, along with an explanatory goal, several scholars recently proposed that mediation analysis can also be tackled by adopting a prediction approach. Well, let's go to the next. A mediation hypothesis posits how or by what means an independent variable X affects a dependent variable Y through one or more potential mediators. How hypothesizing a mediation relationship? Well, there are two distinct approaches depending on whether existing theories and prior empirical research support indirect impact or not. An example of theory where mediation plays an important role, for example, is the theory of reasoned action. According to this theory, the behavioral intention here mediates the effect of the attitude toward the behavior and the actual behavior. Well, we will now explain the two existing approaches for formulating mediation hypotheses. On the one hand, the segmentation approach is applied when there is no theoretical support for the indirect effect from literature. This way, in step 1, we develop a hypothesis for the effect of X on M. In step 2, we develop a hypothesis for the effect of M on Y. And finally, we conclude by stating the hypothesis for the mediation effect of M. On the other hand, the transmittal approach is used when there is theoretical support for the indirect effect from literature. In this way, in only one step, we develop the hypothesis that M mediates the effect of X on Y without needing to articulate hypotheses relating X to M and M to Y. Okay? Sample and complex mediation models. On the one hand, sample mediation models take the form of an independent variable proposed to affect a dependent variable through a specified mediator. It involves only one mediating variable. The terminology used in this context is the following. Direct effect, C prime, it refers to any influence of X on Y that is not accounted by M. Indirect effect, A times B, it reflects any portion of the relationship between X and Y that is accounted for by M. And finally, total effect, C, it refers to the overall influence of the independent variable X on the dependent variable is the sum of the direct and the indirect effects. On the other hand, multiple mediator models extend basic mediation models through the inclusion of one or more additional mediation. We can distinguish between parallel mediation that involves two or more mediators that are proposed to operate in parallel to explain the effects of X on Y, and serial mediation that involves two or more mediators that are proposed to operate in sequence. Next, we will address the topic of testing mediation in PLS-SEM. The question is, how can one tell if their data supports mediation? Firstly, don't forget, the central issue in mediation is whether an indirect path exists. That is the A times B product term significant? That's the key. According to Roldán et al. 2021, we can distinguish two types of mediation analysis methods. On the one hand, implicit procedures. There are traditional methodologies that infer the mediation effect by doing a series of individual inferential tests of path relationships between the dependent and dependent variables. Their logic is neither based on the estimation nor inference of indirect effect. The best known implicit method is causal step approach. On the other hand, there is explicit procedure. They infer the mediation effect A times B by an inferential test of indirect effect. Among the explicit procedure, bootstrapping is the most widely used and recommended method for PLS-SEM mediation analysis. Since this method is well known to the audience, I will not dwell on its explanation. Following the contribution of Zhao et al. 2010 and the adaptation to the PLS-SEM context developed by Nitzl et al. 2016, I present this decision tree to determine the type of mediation analysis. It includes two steps that reflect the general recommendations for mediation analysis. In step 1, we determine the significance of the indirect effect. In step 2, we establish the type of effect or mediation. Therefore, if the indirect effect A times B is significant, we assess the significance of the direct effect C prime. If the direct effect is not significant, there is only an indirect effect. Okay? One moment, please. Here you are. This situation has been defined as a full mediation. It means the effect of the independent variable X to the dependent variable Y is completely transmitted with the help of a mediator variable. In case the direct effect is significant, we have a partial mediation. This means that the independent variable X simultaneously influences the dependent variable directly and indirectly via the mediator. Then we should assess the sign of the product A times B times C prime. If the result is positive, we have a complementary partial mediation. The direct and indirect effects present the same sign in this case. But if the product is negative, we obtain a competitive partial mediation. In this situation, the direct and the indirect effects have different signs. In case the indirect effect is not significant, we don't have any mediation. So in this case, the options are only direct relation and not effect. Well, in the following slides, we will address a series of issues subject to debate in the field of mediation and recommendation to be followed to resolve this point. First point, partial versus full mediation. Some researchers feel that distinguishing between full and partial mediation is pointless and that these terms should be dropped. What are the reasons for this approach? First, because such a distinction is focused on p-values as opposed to the effect size. Second, that distinction is not related to the specific test of interest, that's to say, A times B for the mediation analysis, but it derives from the significance of C prime. Third, the sample size strongly influences the significance of the direct effect C prime. And finally, the use of the terms partial or full mediation can impede research. Regarding this last point, for example, Rucker et al. 2011 note that the full mediation suggests that the effect of the independent variable on the dependent variable is accounted for entirely by the mediator. The conceptual implication of such a conclusion is severe. No other intermediate processes exist. However, Rucker et al. Demonstrate that it's empirically possible to obtain evidence for other indirect effects even when the conditions of full mediation are met. For this reason, Rucker and Preischer 2019 provide the following recommendation. Move away from the terminology of partial versus full and instead focus on quantifying and reporting effect size. The second issue is related to the null hypothesis significant test and the use of p-values. Scholars in many fields have long advocated that the research move away from null hypothesis significant test and p-values as the primary source of support for their hypothesis. A primary criticism of the NHST is that p-values provide no information about the size of importance of effect. Given the relevance of statistical significant degrees in social science because of the increasing availability of large datasets, Moheri et al. Have recently urged paying attention to the notions of relevance and practical significance. This is why Lashovit et al. 2018 give this recommendation. Focus again on estimating and reporting effect size measured as a way of quantifying the magnitude of effect. Given the recommendation for addressing the two previous issues is the use of effect size measure, I will now focus on two types of effect size measure designed for mediation analysis. Researchers might use these measures in parallel with traditional mediation testing. I will start with the oldest proposal, although easy to implement and understand. I refer to variance account 4, the ratio that compares the indirect effect with the total effect. It's applicable only in case of complementary mediation. That's to say, when A times B times C prime is positive. BAF equals indirect effect over total effect. And BAF will help determine the portion of the total effect attributable to the indirect effect and can be reported as a percentage value. In fact, the total effect can be decomposed into direct and indirect effects using a pie chart together with percentage values. I'll use a mediation model of the relationship between satisfaction and loyalty analyzed by Picon et al. 2014. In this case, both indirect effects are significant. However, as you can see, using BAF in percentage and a pie chart, the relevance of the indirect and direct effects can be quickly grasped. You can see here that the indirect effect via PSC, perceived switching costs, is 14.7%, and the indirect effect via attractiveness of alternative is only 2.7%. As you can see, most of the total impact of satisfaction or loyalty is carried out by the direct effect of satisfaction. The effect size nu represents one of the novel measures of effect size for mediation analysis. It has been developed by Lashovit et al. 2018, and the effect size nu is interpreted as the variance in Y accounted for jointly by N and X that corrects for a spurious correlation induced by the ordering of variables. The effect size view equals A squared times B squared. Although Cohen's benchmark for proportion of explained variance can be used, there are no still consolidated thresholds to interpret the magnitude of effects. I'll use again the same previous study to describe an application of the effect size new. You can see the indirect effect via perceived switching cost is 0.01, and the indirect effect via attractiveness of alternative produce a new effect of 0.0005. Very, very, very small. The third issue is related to cautions regarding causal inference. Although mediation analysis provide a means for research to investigate causal processes, models that describe mediation effects on their own cannot prove causality. The fundamental conditions necessary for making causal inference are: first, association; second, temporal precedence of cause before effect; and third, isolation of the causal effect from confounding variables. Laschowitz et al. Provide additional assumptions required for the indirect effect to be considered a causal effect. I focus on the second point, that's to say, sequential ignorability, meaning the effect of X on M and X on Y, as well as the effect of N on Y, are not confounded by omitted variables. We thus provide the following recommendation. First, use past theory or logic to support positive causal mediation relationships, as we have previously defended. And second, and very important, I know that Christian Ringel will be very happy. Conduct an endogeneity analysis of the model to identify omitted variables, using, for example, Gaussian copulas. Described the first time in the context of PLS-SEM by Hult et al. 2018, and recently by Becker et al. 2021. The fourth issue is the use of the highest process macro and PLS-SEM. Numerous studies have used the process routine proposed for regression models to analyze mediation effects using PLS-SEM latent variable score. Sartre et al. In 2020 had tried the following recommendation: avoid performing that kind of tandem analysis because PLS-SEM bootstrapping produces more reliable results than process. And finally, application of explicit procedure of mediation analysis without including the direct effect C prime. Certain studies concentrate exclusively on the mediation effect, omitting the direct effect C prime between the independent variable and the dependent variable, as Rasolin et al. In 2021 have discovered. However, this approach entails a notable bias in the estimation of the indirect effect, which may be inflated due to not controlling the effect of X on Y. As a result, the probability of encountering a type 1 error may increase. Then, this is our recommendation. When testing a mediation relationship, always include the direct effect C prime between X and Y, although this effect doesn't necessarily have to be hypothesized. My last slide is about mediation from a prediction perspective. PLS-SEM is a joint causal predictive approach to modeling complex causal mechanisms. Although mediation analysis can be tackled by adopting a prediction approach, the predictive methods designed so far for PLS-SEM have not sufficiently investigated the role of mediators. In a forthcoming paper, Nicholas Tanz proposed, on the one hand, 3 methods for generating prediction for mediated model. On the other hand, and what is more important from my perspective, a metric that quantifies the predictive contribution of the mediator. In order to give evidence of predictive validity of mediating relationships, this PCM metric analysis should be frequently undertaken in parallel with traditional mediation testing. Therefore, high levels of predictive validity will confer academics and practitioners alike that result may be generalized to other datasets and potentially similar circumstances, boosting confidence in the inferential findings. Well, this concludes the session on modeling mediation effects in PLS-SEM, and now is the turn of my colleague, Professor Gabriel Cepeda. Thank you very much for your attention. I'm close.
Thank you, José. One moment. Okay, it's okay, no? One moment. Sorry about it. Okay. Okay, it's my turn. My part is about modeling moderation effect in PLS-SEM. Like José and Christian said, my name is Gabriel Cepeda from University, from Universidad de Sevilla, no University of Sevilla, but the real name is Universidad de Sevilla. I'm going to try to explain some issues, no, about moderation analysis, no. One moment. Okay. Well, in order to start, no, we can say that one moderating effect, no, is caused by variables that change the strength or direction of one relationship between an independent variable or construct, no, and dependent variable or construct, no. These effects are caused, no, by a type of variable named moderator, no. You can see in the figure, no, three types of variable, no, independent or exogenous variable, X, the dependent variable, Y, also name it endogenous variable, and this one, M, is the moderator variable, no. We can find typically two types of moderator, no, according to the nature of variable, no. So we have categorical moderators such as gender or social class. They are categorical, and continuous moderator, no, that's as the income, age, and so on. And the analysis of categorical moderators for moderation are different than continuous variable, no. I'm going to try to explain, no. And before that, no, I try to give a tip in order to identify, no, potential moderator, no. As for all effect analysis in PLS-SEM, except if our purposes is pure exploratory, no, we need some kind of support to identify potential moderator, no. Option, no. The first one is always the literature, no. The choice, no, should be based on some theoretical foundation, no. The literature review are very important in order to find variable entering in the models, no. The second one are the find consistent result for previous studies, no, on the effect of the same antecedent variable on independent variable, no. Also the use of a contingency factor from a different scientific field, no, in order to move that from this scientific field to my scientific field, no. The fourth will be using the dialogue with expert in the same field, or key informer in the relevant industry in order to identify potential moderator. The experts are a good source of knowledge, no? And finally, the qualitative research comes here, no, to explore and propose a possible moderation effect when a contingent variable is considered relevant, but has not been yet, no, empirically tested in the same field study. No? As I said, no, I'm going to make an overview about how perform moderation analysis in PLS-SEM using the two types of moderator, no, categorical and continuous. When the moderator is categorical, the moderation analysis is carried out through an NGA, no, the multi-group analysis. The multi-group analysis is born for considering heterogeneity exist in our data set, no? Two sorts of heterogeneity, no, exist, observed and unobserved. The observed occurs when the moderator is clearly identified by one researcher, no? However, in the case of the unobserved heterogeneity, no, researchers do not know which is the moderator. Anyway, no separating group effect, as we see next, no, have main implication in the result finding. Yeah. In the figure, no, you can see a typical simple model of moderation with the independent variable, the dependent variable, moderator, and in the chart, you can see how the relationship is different for high values of the moderator and the low values of the moderator. This is the relationship. No? Also, as we already say, no considering the effect groups, different values of a categorical moderator in the sample, men and women. No, suppose that the parameter estimation not differ a lot. No, so if we run PLS-SEM with the test data set, the parameter estimation for the two relationships exhibits in the sample, no, quality on car purchase intention, on price on car purchase intention, no, are in both cases 0.30. Well, one difference happen with regard to the parameter estimation when we split the data set in two values, no, men and women. With the sample is composed only by men, the parameter estimation is 0.50 and 0.25, respectively, for these relationships, no? However, in the women case, these parameters are 0.10 and 0.35. Therefore, no, if we will not consider the heterogeneity in the parameter estimation with the full data set, cannot be sometimes very accurate. This chart, no, from a paper of Cheah et al. in 2020, no, sounds very well, no, the thing that we need to carry out an NGA analysis correctly, no? And the stage one is data preparation, generate data group, the MECON, or the invariance, the measure invariance test, and finally, analyze using MGA approaches, no? Different approaches, no? But it's not the issue of this presentation, or the objective of this presentation, no? Some simple ideas that you need to run an NGA. The first one is divide the sample into subsamples or categories. The second are the method to divide. The first one would be categoric size observation according to the level of the moderator variable. Usually the dichotomization. No? Another option is doing a typical cluster analysis. And the third one is very similar but different, a bit different, no? Is doing a polar string approach. The polar string approach consists in making 3 clusters and only compare those ones at the extremes. For example, if you make 3 clusters, you compare the cluster 1 and the cluster 3. Next, we need to estimate the path coefficient for each subsample by PLS. And finally, you have to test the significant difference between the path coefficient and also interpret it as moderating effect. No? If the difference is significant, you can interpret that difference, that significant difference, as moderating effects. As we say, NGA only is possible when you have different data groups based on a category of a concrete variable. No? Therefore, it's especially easy when the moderator is one variable. But what happens when your moderator is not categorical, but continuous, or with a matrix scale? Could I run an MGA analysis? The answer is yes. But before, you need grouping the different values on that variable to transform in categorical. How? One option, the options are the cluster analysis, the dichotomization, and so on. And then we can run the NGA, and we can estimate the parameter for a determined value of a moderator, no? High and low, and afterward for another group, and compare the difference and see, and if this difference is significant, you have a moderation effect. The MGA approach are well known, and the explanation in down, we can say no, it's not this presentation objective. Nevertheless, no, I do want to comment on recent approach developed by Nitzl in 2019 in Internet Research. This author proposed a new permutation test that allowed the whole model to be compared between 2 or more groups. And it's appropriate if there are no prior expectations about which part of the model can differ, or if you are interested in whether a posteriori theory or a completing model work differently between different groups. What is implemented in the CSEN R package recently published and available for Michael Rademacher and Florian Schubert. You can see the documentation in this link. Another option to carry out moderation analysis in PLS-SEM is when the moderator is a continuous variable. The moderation is performing through the sometimes named interaction effect. How works it? No. 3 approaches are considered to estimate moderation effect in continuous variables: the product indicator approach, the orthogonal analysis approach, and the 2-stage approach. This chapter or this figure show the typical moderator analysis where, for example, the decisionless variable or independent variable could be satisfaction. Here, the indigenous variable or dependent variable will be loyalty, In the middle, the moderator variable, for example, income, no? Three parameters to estimate, D, B, and C. B is the main direct effect when the moderator is not present. D is the simple effect when a moderator is included. And C explain the variation in Y explained by M. This relationship is a mathematical requirement in order to run a moderation analysis in continuous variables. Using a question, so the direct effect equation would be this one. If I include in the moderation effect here, would be that one. Rewriting the equation as follows. The iteration term here. And if the D parameter is significant, there will be moderation. You can see this figure or this model have an equivalent model running in SmartPLS software, for example. We can find three variables, no? The independent variable X, the moderator variable M, and the iteration term X for M. Important. Only when the D parameter is significant, there is a moderation effect. No matter the significance of B and C. In our example, the variable could be satisfaction, loyalty, and income. Something more complex. If you want to run a double moderation, also named a three-way iteration, the equation would be this one. And this is a typical three-way iteration model, and the equivalence is this one. You can find the moderator variable, the two moderator variables, N, M, the independent variable X, the three simple moderation effect, F, F, and G, and the double moderation, the X on Y, using moderation for by M and N. Well, when the H parameter is significant, there will be a double moderation. If this A parameter is significant, the moderation, the M moderation, there will be a moderation. The same happen to N and so on. Okay, it's a little complex, but it's interesting. It's used for one concept called how the concept of synergy, no? The sum of the part is more than the part summed, no? Some important issues about moderation, mainly for continuous variables. Well, the continuous variable approach is an advanced modeling of the moderation effect. Wherever possible, it should be chosen. If the constant measure does not vary between groups for categorical variables, the two approaches tend to provide very similar results. With continuous variable, the MGA approach could be applicable using the customization. Sometimes the use of ensure that MGA is widely used by researchers. It's very illustrative, no? As conclusion, no, since the result of the continuous variable approach are usually equivalent to or better than those of the multi-group comparison approach, we recommend the use of the continuous variable approach at all time, only if the moderating variable is categorical. Sure. Or if the researchers want to get a key overview about a moderation effect, the MG approach could be considered. How we say, no, there are three prominent approaches: the product indicator, the auto-organizing approach, the two-stage approach. But some issues about that. The product indicator approach is only used whenever either the independent variable and the moderating variable are factors or are measured by one indicator. It happened very few in PLS. What happened in PLS? Using the two-state approach and the auto-organizing approach. Why? The two-state approach is used whenever any of the variables created in the iteration term are composite. When using the auto-organizing approach, is used whenever we think that there may be high potential multicollinearity in the construction of the moderator term. It has the disadvantage of low statistical power because the parameters of auto-organization approach are very small for them, for that, the low statistical power. And also a problematic of overestimation tendency. The two-stage approach is more likely to be successful in parameter estimation and statistical power. Tip: use the auto-organization and the two-stage approaches as a rule of thumb in PLS. Two slides more, and the first one. And to sum up, to analyze moderation effect, the different coefficient of the exogenous or independent, no, and of the moderation variable, coefficient B and C, as well as the ratio of the moderation term has to be examined. The moderation hypothesis is supported if the D parameter is significant. To determine that significant, using bootstrap. To determine the strength of this moderation effect, the F-squared ratio, FXI, is used. Important. The model to compare to the FSI is the moderator radius unit include the moderator relationship in your direct effect model. And compare that model with the direct effect and the included interaction term. When you compare that, you obtain the F squared. What is the power or what is the effect size of the moderation effect? If F squared is higher than 0.02, the moderation effect is weak. If it's higher at 0.15, the moderation effect is medium. And it's higher than 0.35, the moderation effect is strong. Sometimes the interpretation of moderation result could be quite challenging, no? And a graphical illustration of result, no, or results is useful to interpret and show the moderation result. SmartPLS offers that slope plot in the final result option when a moderation analysis is executed. Other additional resources are in the Jeremy Dawson webpage and the Christopher page webpage. You can see the link there, no? and it's very interesting to interpret graphically the result of the moderation. Well, I finished my comment here about moderation analysis. Jacky, it's your turn. And thank you very much. And sorry for my bad explanation.
All right. Yeah. Now I have to share my slide, so I will wait for this slide to exit. Yeah. Okay. Now let me share the slide. Okay. I hope you guys can see my slide. If yes, just let me probably give me an emoji thumbs up. Then I know that you can see my slide, right? Yeah. Can you see my slide? Yeah. I saw some message. Yes. Okay. Great. Fantastic.
Yeah, we can see.
Yeah, fantastic. So yeah, I'm about to start. Let me turn into this slide. Okay. Again, I would like to thank to my colleague for having me together to further share this particular session, right? I hope you guys are still doing fine with the overloaded information, especially on this interesting topic on the mediation and moderation effect in PLS-SEM. However, we're about to kickstart one of these most anticipating topic, which is modeling conditional mediation effect in PLS-SEM. To keep it short and simple, it is like, people always say mediated, moderator, moderated, mediated. So those kind of, topic that we are going to go details. Okay. So back to the basic, once you know mediation, you know moderation. So what is conditional mediation effect all about? So conditional mediation, this analysis, it combines or integrates mediation and moderation analysis to examine and test hypotheses about mediated relationship. And this mediated relationship could vary because of certain degree in terms of context, boundaries, or individual difference. Put it into another words, for example, such as like gender, nationality, policy making, we could have different perception and thoughts. And this could vary the mediation effect. According to Hayes, 2021, this is the latest book, the third edition, it stated very clear that Common effect represent an effect which is mediated through M, through which X exerts its influence on Y and depend on the value of moderator, that is W. So in other words, the value of mediator effect changes depending on the value of moderator in terms of magnitude, size, or direction. So the big question here is, when should we do conditional mediation effects? It is sensible enough to say that you can do this test if A or B, or should I say the path 1 or path 2, which is A and B, which is the indirect effect, either one of this direct effect is moderated, then you can somehow test these conditional mediation effects. To keep things simple, let me put in an example. We have this famous book, of course, everyone know, Hare et al. 2022, a primer PLS structural equation modeling book, which is the third edition. This is the latest book. Have these famous examples that number of swimmers could be a potential mediator that mediates the relationship between seawater temperature and number of incidents. This mechanism is super interesting. However, if you would like to extend this to one step further to understand the complexity of human behavior, we could look into one of the moderator effect, which is from the big 5 personality called conscientiousness, right? If this conscientiousness moderates either path A and path B, then we could see that there are different conditions, which means that probably there are people that is high conscientiousness. People that is high conscientiousness, they are more careful, they are more disciplined, they are very concerned about themselves, they are very organized. This could weaken the relationship of number of swimmers as the mediating effect. However, if there are low conscientiousness, it could mediate or weaken the mediation relationship of number of swimmers. And this further explains why many people today are interested to examine this conditional mediation effect, right? So back to earlier what Kristen Nitzl have said, as well as José Luis Roldán, stated very clear that this paper, Susted et al., stated one thing that is very interesting. many people still depend on like using SEM and macro process together to estimate like certain mediation effect or maybe conditional indirect effect. My answer to you is this is very true because it is still in infancy stage that many people don't aware the whole steps and the process to assess this method. We, in our paper, review of papers from the Web of Science database from 2000 to 2019. We found that there are a few papers, which is all total 27 papers, conduct on this COMI analysis or conditional mediation. And these are from the field of like marketing, information system, as well as hospitality and tourism. If we go one step further, looking into these 27 papers, 11 papers of them combine both technique, PLS-SEM, save the latent variable score, and run process macro. This already well stated by Suster et al. 2020 that there are certain degree of bias if you combine this tandem process approach to estimate this conditional mediation. Of course, when the model becomes more complex, the error will become higher when you do this combination between PLS and process macro. On top of that, there are 16 more studies that perform multi-group analysis to claim that there's a COMI effect using a categorical variables. This is true, but based on this 16 study, 14 study did not examine the difference in the mediated effect before comparing each group mediated effect values. To keep things simple, it is comparing the indirect effect of two groups. They just report indirect effect of group 1 and group 2 without comparing the difference. And this is not the right process. Worse still, many people are very data-driven. They don't focus on theorizing or have a strong theoretical reasoning when develop a COMI model or COMI relationship. With this, we also would like to talk about rate of change and difference in strength in the later stage. So why it is important to examine conditional mediation model? Like what I stated earlier, human behavior are super complex, especially when you talk about studying social science behavior or maybe business behavior and so on. Because there's so much complexity in human behavior, you cannot treat this relationship like just I want to test mediation, like X lead to M lead to Y, and full stop. It will not happen that simple way, because examining mediation is not always a universal process. Most important, it is like bivariate and linear relationship, because if you look in bivariate and linear relationship, X on Y can always be moderated by any third variable, which means if you put mediation with a moderator, you could see that the mediated effect value is conditional on the moderator value. And this is considered one of the most interesting parts that many researchers out there and practitioners out there would like to further investigate such complexity behavior, which means how the moderator influences the mediated effect value. And it could be in the first stage path, the second stage path in mediated relationship, or maybe both. Simple as that. So can we really do conditional mediation analysis in PLS-SEM? If you look into a lot of software like M+, famous software, right, for covariance-based SEM, or maybe Lawan, R package, or maybe the upcoming package, software, Gesca Pro, they somehow stated very clear in their manual, their website, stated that, oh, we can do conditional mediation model. But the bigger question that I want you to focus in right now is, can we really do it in PLS? Especially SmartPLS, because we have many users that use SmartPLS, right? So can we do it? Our answer to you is definitely a yes. My colleague and I, which is Christian Nitzl, José Luis Roldán, Gabriel Cepeda Carrión, and Sigi Gudagan, have come out this decision tree for you to take a look, right? When you want to conduct a COMI analysis. To conduct this conditional mediation analysis or COMI, the first step that we would like to advise you is to determine the goal of analysis. There are two branches that you can see. One will be the rate of change or slope. The other one will be path difference. What is the difference between these two? Rate of change or slope is somehow like when moderator increase, what will be happen? The mediated effect. This is what we call rate of change or slope. For path difference is to see which of the indirect effect is stronger, either group 1 or group 2. It is more obvious type of explanation. If one would like to embark in the journey of rate of change of slope, then they need to ask themselves the next question. What is the type of moderator? If the type of moderator could break into two, either continuous variables as well as categorical variable. For continuous variable, it could be a very clear cut. If you look into the primer book of PLS, it would be like switching cost, could be a potential moderator variable. If you look into a categorical variable, it could be nominal data such as gender, nationality, or maybe one would like to do an experiment study comparing treatment group versus control group. This is often do in consumer behavior or marketing study when people do experiment. Then with these two variables that you know, researcher can actually analyze using the interaction term approach. When you analyze using interaction approach, it is a similar standard approach like you run in moderator, in which you have two-stage approach, product indicator, as well as orthogonalization. Running this approach, researcher could one step obtain and to test the index of conditional mediation. To test this, if it's significant, we look into this branch. If it's significant, we can claim that there's a conditional mediated effect. Subsequently, researcher can actually produce and interpret the interaction plot of the conditional mediated effect, or maybe look into the mean plus or minus 1 standard deviation. If the index of conditional mediation is not significant, we will advise researcher to analyze and report the moderation and mediation separately. If one would like to embark in this journey, which means the path difference, then the similar question should ask to the researcher, what is the type of moderator? The type of moderator still the same, can break into two types, which is one is continuous variable, one is categorical variable. For categorical variable, it is clear cut that you can easily run it in MGA approach. But for continuous variable, we will advise researcher to dichotomize the variable, either like median split or mean split to analyze the MGA approach. However, be cautious for one would like to embark this continuous variable when testing path difference, because when you split your data, you will somehow lose statistical power. It is obvious in the literature, documented in the literature. But again, I would not like to deny that the fact that you cannot use continuous variables to dichotomize, because if you would like to report your findings to practitioner, not academic, practitioner, you would not want to tell them what is rate of change of slope. They would not understand. They would rather to know what is the path difference, because it is easier to understand. So when you run the MGA approach, you first need to test on the difference in the mediated effect between groups, which means the difference between the two groups of the indirect effect. If it's significant, then you can compare each of these conditional mediated effect between groups to see which effect is stronger for A indirect effect group or B indirect effect group. On top of that, researcher can go one step further to determine the type of conditional model. To determine this type of conditional mediation model, researcher need to look into the two paths, the P1 and P2, which means the A multiplied with B. If the P1 is significantly different, researcher can claim this as model A. If it is only P2, researcher can claim this as model B. If it's P1 and P2 both, then researcher can claim this as model C. However, if the difference of the mediated effect is not significant, then we will advise researcher to analyze and report this moderation and mediation separately. Simple as that. But right now, the next question is, give me a second. Yep, the next question will be, what is the type of conditional mediation model? Why model A? Why B? Why C? To keep this simple, we will put aside the Hayes like 72 model, 1801 models. We will put aside this. We just take those like the most familiar one to show you showcase you what is the type of model A, B, C, D, and E. And if you do a rate of change of slope, you can do more, A to E. But if you do a category path differences, you will do lesser, which is model A, B, and C. So I will explain more detail what is all this model about. Give me a second. So to reiterate again, the first step when you do a common model, make sure researchers should be theory-driven rather than data-driven. I believe that when I saw a lot of research that, trying to submit to a journal, when I tried to review their paper, a lot of research are based on data-driven, not theory-driven, and this is bad. So our advice to you is like the first step, focus on the goal. The theory-driven hypothesis that you can specify for a common model is to look into two objectives, whether rate of change or maybe difference in the strength of relationship. If you would like to embark in this rate of change, your hypothesis that you have to derive is something that look into number 1 point, which is the mediated relationship between X and Y increases as W increases, or maybe vice versa. If you like to embark in the second goal, which is difference in the strength of a relationship, then we will advise researchers to embark into the second point, second example, the mediated relationship between X and Y is greater for one group, or maybe high values of W, than for low values of W. This is, or maybe vice versa, right? So there are two ways for you to write hypothesis, and researchers need to determine in the early process before going to the analysis. Now, once you have clear with the goal of conditional mediation analysis, regardless rate of change or slope, or maybe path difference, now we will talk about type of model in conditional mediation. There are 5 types, which is the most simple one, A, B, C, D, and E. And right now, I will explain to you guys. If you look into model A, it's the most standard one. Often you see, where you see X predict on M predict on Y. W will play as a role of moderator. So when W interacts in between of X and M, it will be X interact with W. Look into the statistical model on your right-hand side. It looks like very basic and standard, like you are doing a moderator, right? But when you look into the equation of conditional mediation effect, the formula will be omega equals to P1 multiplied with P2 plus P2 multiplied with P5 multiplied with W. And this W is the moderator standard deviation value. So this is important. I want you all to take note this formula because later we will continue to use this example. But right now, I want to draw your attention. Once you have run the interaction approach, this is important, but the most important for you to run a conditional mediation is to see the index of conditional mediation, whether it is supported or not supported. For model A, all you need to do is P5 multiply with P2, which is this formula. If this is significant, it is like somehow like your indirect effect from here, here, and here, somehow like your indirect effect. And if this is significant, then that's good because your index of Comey for model A works. And the good thing about SmartPLS, now I'm going to say SmartPLS, is if you want to do a model A, you can get this result directly from SmartPLS output, which means you can do a conditional mediation for model A in SmartPLS, right? You can get this output. And if this index is significant, then there's a Comey effect. Simple as that. Now, let us move on to the next example. The next example is model B. Model B is the W moderates at the second stage of the mediation model, which means the W moderates between M and Y. The statistical model looks into the right-hand side. So to calculate the index of conditional mediation for model B, you need P1 multiplied with P5. Unfortunately, let me tell you one thing. I don't think a lot of software will generate this result, especially like looking to SmartPLS or maybe Adanko or maybe other software that use PLS. You can't generate this index of conditional mediation compared to model A. This is model B. You can't generate this index. So all you need to do is when you run a bootstrapping, you calculate the path coefficient bootstrapping result and get the sample output in this bootstrapping. From there, you copy this bootstrap result, or what we call bootstrap subsample result, into an Excel spreadsheet and multiply all columns P1 multiplied with P5 to calculate the bootstrap confidence interval. If this is significant, then model B got Comey effect. Model B got Comey effect. So let me tell you one thing. For model A, you can do it in SmartPLS easily. For model B, it's a bit difficult. You need to do manual calculation. Let us move on to model C. Looking into the equation, or maybe looking into the conceptual model, model C is somehow the extension of combination model A and model B. As you can see, W moderates the first stage of mediation model as well as the second stage of the mediation model concurrently. So looking to the statistical model, as well as how to calculate the index of conditional mediation, the formula will be P2 multiplied with P5 plus P1 multiplied with P7. As you can see, P2 multiplied with P5. This is somehow similar with your model A, right? And P1 multiplied with P7, which is this one and this one, somehow similar like your model B. The only difference here is plus. It plus the effect of these both moderated in the first stage and second stage in order for you to get the conditional mediation effect. Simple as that. Now, let us move on to the next slide. The next slide is Model D. Model D is somehow also another extension of Model C, in which you have two moderators right now. If you have two moderators right now, one is W, one is Z. The W moderates as the first stage in mediation. The Z or Z moderates at the second stage mediation model. So the formula to calculate the index of conditional mediation is somehow similar with the early model C. Also the same, in which P2 multiplied with P5 plus P1 multiplied with P7. Simple as that. Last but not least is Model E. This is one of the rarest conditional mediation model that you can see, in which, if you look into the conceptual model, X not just play an important role of predictor or maybe independent variable, but X also could moderate the relationship between M and Y, where you can see the interaction X multiplied with M predict on Y. To calculate the index of conditional mediation, simple, P1 multiplied with P4. If this is significant, then there's a Comey effect in model E. Please take note that if one would use a categorical moderator or maybe dichotomous moderator, you still can run this interaction approach or interaction analysis for Comey model, especially if your goal is to study the rate of change in a relationship. And this can be done by looking into coding, right? Coding in the categorical variable into dummy variable, right? For example, if you have two nominal data, one is prepaid, one is postpaid, one means prepaid, you will represent as dummy variable, and 0 will represent as reference group. Then you can compare the effect. Then
United. José.
Then
Okay.
We would like to also, once we have fulfilled the model 5 model, regardless to compare the index of conditional mediation, this is the first rule of thumb you need to fulfill. If this is significant and supported, one could actually further investigate the representing or representative levels of the mediated effect, regardless maybe low, medium, or high. And this could be looking into stronger, weaker, or maybe opposite in sign. For a continuous moderator, it is very clear-cut. Most of the time, people will use the standard deviation to determine whether it is low, medium, or high. If you are doing a categorical variable, you cannot determine using the standard deviation to represent low, medium, or high, because categorical variable, you can't conduct low, medium, high. Rather, you need to do dummy variables comparing with reference group. Okay, simple as that. So to one step further to know what is the moderated value on this conditional mediation, our manuscript also have shown a table with this equation that is model A, B, C, D, and E, right? So to keep things simple, we just take model A for illustration. For model A, as you can see, when I have stated earlier for model A, you can get the index conditional mediation effect or the output from SmartPLS. But to calculate the different level, you can use back the original formula from model A on this conditional mediation. The original formula will be P1 multiplied with P2 plus with P2 multiplied with P5 multiplied with W. However, if you simplify the algebraic or mathematical formula, you can derive this equation on P1 plus bracket of P5 multiplied with standard deviation of W bracket multiplied with P2. And this standard deviation of W can be varied according to negative sign, 0 value, as well as plus. And it could vary. If you use this formula, you could see the effect of Comey effect varies low, medium, and high. Simple as that. Okay. I just used one example, which is model A, right? For B, C, D, E, yeah, you can read read our articles. Our article provides the detail. So let us move on. If you able to generate the Comey effect low, medium, and high, one could also further up, their assessment by looking into graphical plot. That is data visualization. Many practitioners like data visualization because it's clear, right? So one way to do this is to look into the Johnson-Neyman's plot by Putra et al. 2007. You can do this easily. I'm going to explain this in a short while. So to keep things simple, let us give you an example. If you are planning to conduct a model A, this talk, we're going to show you all just model A. So if you plan to do a model A for conditional mediation, imagine you have price image as your independent, perceived value as your mediating variable or mediator variable, and behavioral intention as your dependent. Then you have pseudophobia as a moderator. To let you all know what is pseudophobia means fear of being cheated by retailers. Consumers have those fear, being cheated by retailers or sellers that always sell product, right? So if people that is high pseudophobia, they are scared, scared of being cheated, then the effect will be weaker. People that is low pseudophobia, the effect is always higher. Okay, simple as that. So when you run it in statistical model, in this study, we use a two-stage approach we run. You will get a simple output from SmartPLS, but what you need to do is look into the index of Comey, P2 multiplied with P5. Like what I stated earlier, to do a model A conditional mediation, you can get the output directly from SmartPLS or maybe other software. The formula to calculate index of Comey for model A, is P2 multiplied with P5. As you can see, this result that I have highlighted, it is like price image multiplied with pseudo predict on perceived value and perceived value predict on BI. This is actually the index of Comey, P2 multiplied with P5. As you can see, the result is significant for p-values as well as confidence interval. If this index of Comey achieved, it means that your model somehow have this conditional mediation effect value. To one step further run this test, researcher can go to the bootstrap, subsample, regardless maybe 5,000 or 10,000, whatever, you like to do, 5,000 according to Hare 2022, the primer book, or maybe according to Strucken and Leroy-Verrot's 2016 stated that do a 10,000 bootstrapping. You can extract this bootstrap subsample result and paste it in Excel. If you are very curious whether the index of conditional mediation is significant earlier using the SmartPLS output, you could actually use this value and this value calculate P2 multiplied with P5, like what I stated earlier, to detect the conditional mediation effect. This could actually verify the earlier SmartPLS output or maybe SmartPLS result on this conditional mediation for model A in terms of the index. So you can verify it. So once you have done this, researcher can further up using the earlier figure just now, the equation that I show in the figure, that model A, to generate this Comey effect at low moderator level, medium moderator level, as well as high moderator level. The equation or the formula here is stated earlier in the figure. Researcher can follow this step to calculate in Excel. Then researcher could actually calculate the path or the effect or the indirect effect for low Comey, medium Comey, high Comey in the Excel sheet by using average formula to calculate each of these low Comey, medium Comey, and high Comey. As you can see, when there's a low Comey, the effect is stronger than the high Comey. The low Comey show 0.144 and the high Comey show 0.070. This is like what I stated earlier. When there's high pseudophobia, the value is weaker, the mediation value is weaker. When there's low pseudophobia, the value is higher. Why? This is pseudophobia, which means that fear of being cheated, right? So that's why the effect is like the other way around, okay? So I hope you guys clear the effects of the average or the path for low Comey, medium Comey, high Comey are very right, in the right manner. Then let us move on to the next step, which means that you have to calculate whether based on the confidence interval, the low Comey, medium Comey, and high Comey, whether it is significant or not. It can be easily significant if you really look into the formula and you calculate the percentile 5% and 95%, right? So in this result, you clearly see that everything is significant looking into the formula, right? Because it is in green color, I highlighted in green color. So with this in mind, to keep things short and simple, you could report your table in terms of this COMI model for model A. First, report on index of conditional mediation. As you can see, the t-value is 2.295. The percentile level also significant. The beta value is 0.037 negative. However, I know researcher would like to ask, what is the difference between this value and process macro? Process macro produce you unstandardized value. This process produce you standardized value, which is actually fit with what SmartPLS or maybe any PLS software that always show the standardized beta value. So this is the result. And on top of that, when you look into the sugrophobia or at different level, you could see that the effect is become weaker from 0.144 drop into 0.070. And all these COMI effects are actually significant, supported. If you want to go one step further for data visualization, you can get this Excel sheet from Preacher 2007. You can actually generate this data visualization. This data visualization is actually Johnson-Neyman's, in which you can see the black line is the indirect effect, the green line is upper bound result, the red line is lower bound. Here is represent low COMI effect. Here represent medium COMI effect. And here at the bottom represent high COMI effect. As you can see, it is somehow a slightly U curve from the red and green. It means that it deviates from the indirect effect when you look into lower bound, upper bound, and there's a significant effect. And this significant effect of this conditional mediation happens in the region 1, which is this region is significant, as well as this region is significant. So this is how you're going to interpret Johnson-Neyman's plot. Of course, you can go more details about this Johnson-Neyman plot, but what I showed right now is just a simple one, okay? Then we are almost done. We have done with the first part, which is understanding how we can do this rate of change or slope when we're calculating interaction for COMI effect. But how about doing MGA for COMI? The answer to you is it is possible, because if your goal is to look into like the path difference, the strength difference, right? Then one could actually do MGA. Let me give you an example, simple one. If you have X, M, and Y as your model, and you have a categorical moderator that moderates the relationship, then researcher could actually split the sample into two, in which the group 1 could be like, for example, male group 2 maybe female group, right? So you can compare these two groups effect, right? However, if you want to test on conditional mediation effect, you need to go into the formula of, as you can look in the bottom, which is to calculate the conditional mediation effect. You could look into the formula of D, which means difference, equals to P1 multiplied with P2 for group A minus or subtract P1 multiplied with P2 for group B. If you're able to minus and there's a significant result of big difference, then researcher can further up by running this indirect effect, okay? So why it's important to run this conditional mediation analysis, this effect? For example, again, if you have group A is male, group B is female, and if you run this indirect effect and compare, you could see that in group A, it is full mediation, that's an indirect effect. In group B, you do not have mediation effect, but only direct effect. And that is the advantages why you can use MGA to run an indirect effect, or use an MGA to run a conditional mediation model. So to run this MGA, this is what stated earlier by Gabi. Gabi has stated that you first need to back to the basic, run the measurement invariant test. And this measurement invariant test, you can look into MICOM according to Henseler 2016. There are 3 steps: configural, compositional, as well as composite equality. From there, if this is fulfilled, regardless full invariance or partial invariance, researcher can move to step 2. So in step 2, you can analyze MGA approach. Our advice, also my colleague. So if you are doing 2 groups comparison, we will advise you to use permutation test by Chin and Debin 2010, which is the most best or stable approach. If you compare more than 2 groups, we will advise you not to use omnibus anymore. Use the non-parametric distance-based test by Klessel et al. 2019. Of course, not to forget, if you compare more than 2 groups, you also need to look into controlling the family-wise error, which means controlling the bond form, controlling the effect of comparing more than 2 groups by using Bonferroni correction as well as Sidak correction. This is stated by the advanced PLS primer book. So to summarize this, how to run MGA for COMI model, of course, researchers need to look into the D. Again, this D represents the conditional mediation effect for COMI model, right? For conditional mediation model. So if you want to compare two groups indirect effect, first of all, check on the difference. The difference will be P1 multiplied with P2 for group A minus or subtract P1 multiplied with P2 for group B. If there's a significant and is support, then researcher can actually interpret the indirect effect from group A, group B separately or in detail, in which you tell that, oh, some could have full mediation or partial mediation, or both is like significant or not. So this is the step. And finally, not to forget, researchers should go one step further to test also the differences in the direct effect of the moderator for path 1 or path 2 or A or B. Why? This is what we call posteriori step, in which it helps you to determine the type of conditional mediation model. If only P1 is significantly different between group 1 and group 2, we can claim this as model A. If only P2 is significantly different for both group 1 and group 2, we claim this as model B. If both P1 and P2 are significantly different, then we claim this as model C. Why we suggest this approach? This approach also somehow looks like the post hoc test, but why we suggest this? Because remember, back to the basic, PLS, when they estimate model algorithm, it is partial information approach. It is not full information approach like CDSEM. It is partial information approach. So when they run assessment or estimating a model, they are running by component or blocks. So when they run by component or blocks, to ensure that your COMI modeling effect on MGA works robustly, you need to run a posteriori step to check which of the type to determine the conditional mediation model. This is the advice. So to keep things simple, not to confuse you guys, we use back the same example: price image, perceived value, and behavior intention, and gender as part of moderator. So for gender, we dummy coded it that female is 1 and male is equals to 0. The first thing that you need to do is calculate the difference of P1 multiplied with P2 for female group minus with P1 multiplied with P2 for male group. If there's significant and it is supported, then you can claim that there's a COMI effect in this model. So to keep things short and simple, first, interpret the difference in the mediated effect between female and male consumer. In this result, we use a permutation test and we compare the indirect effect difference between female and male, and the difference will be 0.136, as you can see the value, and the permutation p-values is significant. From there, you can move into step 2, determine the type of COMI model. To determine this type of COMI model, researchers should look into each of the direct effect moderated value. As I stated again, it is partial information approach if you use PLS, or maybe it estimates based on component of block. So you need to check on P1 and P2 rigorously every moderator effect. But based on this result, it's only P1 significant moderator. So we can claim this as model A. Last but not least, we can determine the type of mediation for both groups. Maybe in this result, you can see that female and male indirect effect is significant and the direct is also significant. We can claim that female and male, both of this subsample, are actually partial mediation. So we are done, and we have conclusion and key takeaways for you guys. The first question to you guys again, is it worth to conduct COMI analysis? My conclusion and my answer to you guys is yes. It opens up new avenues for analyzing new research questions, especially trying to understand deeper insights, behavior, or intricacy of processes under which condition they occur, which means that it will lead to theory advancement, or maybe contribution, or maybe novelty in your work, especially when you do empirical study. And my final conclusion, there are always a lot of naysayers. I use the word naysayers, that, you know, in social media or maybe somehow in ResearchGate, they state that, oh, PLS-SEM, PLS-PM can't do this conditional mediation analysis, or somehow they, you know, bash on the software and they say that software cannot do conditional mediation. You need to depend on process. Our answer to you, it is over-exaggerated. It can be done. It's just the mathematically formula behind that you can implement it, calculate it in Excel to run this conditional mediation. And finally, our recommendation and our key takeaways, we have 3 for you. First, model specification. I couldn't stress much, right? A lot of empirical researcher, I do not want to talk about methodologies or maybe statistician, because they are different way of doing research. But when you look into empirical researcher, they often like to torture the data until the data works, until the result works, right? So when you do a COMI model, please don't do so, right? It is a bad process. You need to follow a proper guidance, a clear and robust theoretical basis to establish this COMI model, regardless if it is first, second, or maybe both first and second stage of moderator mediation, which means either model A or model B, or maybe both. This is how you need to have a strong theory to build up this model. This is not from me, it's by Holland et al. 2017. Not to forget, we also encourage researchers to hypothesize argument concern. When you hypothesize COMI model, make sure it is either rate of change or maybe difference in terms of strength, right? So you need to choose either one. The second key takeaways is, a lot of researchers always say that, mediation, right? Let us do a cross-sectional research design to conclude there's a causal inferences in our mediation. This is also similar with COMI, right? For mediation, it also implies causation. For COMI model or COMI analysis, it also implies sequential causation. Researchers need to aware, they need to stay away from causation and correlation. They are both different things. So the best way to produce the best result of causation inferences, we will advise researchers to use experiment and longitudinal research, right? This is the most welcome in terms of causal inferences. However, if you have no choice, right, you want to just do it in cross-sectional research design, which means you collect one time of particular data and just run your model, then we would not want to say, no, you cannot do it. We would like to advise you at least perform a certain control variables to control the confounding effect, or maybe perform a control endogeneity test, such as using the Gaussian copulas by Hawk et al., the team and his colleague, 2018. In PLS, you can perform these Gaussian copulas. And for more reading about these Gaussian copulas on endogeneity, you can read the latest paper published in Journal of Academic Marketing Science by Becker, Prakash, and Ringel. Okay. And finally, not to forget our best nightmare sample size, right? To do any analysis, regardless interaction or MGA, to detect COMI effect, make sure you have sufficient statistical power, because it helps you avoid type 2 errors. To do so, check out the power analysis table by Hare et al. 2022, or maybe you can perform a G-power analysis. Last but not least, you also can use the Koch and Hadaya 2018 to look into the inverse square root method as well as gamma exponential method. That could somehow determine the minimum sample size or optimum sample size for you to estimate your COMI model. For further details, we are done here. We will advise you if you want to know more detail, because what we are sharing here is like the basic one. So for more details, you can go to our ResearchGate to get a piece of this paper. This paper is not the clean or the ready format. So you can take a look at this copy of this paper to know more details inside how to perform other model like model B, model C, and other small components or key takeaways. You can read that paper. And finally, I would like to acknowledge also, if you can see this prelude tree, we have like 4%. I would not want to, put aside. I also want to give a shout out to our co-author, Siegfried Gudegan. I do not know whether I pronounced correctly his name, Siegfried. I always call him Sigi Gudegan. Sounds easier. I could not find his best picture. The best picture is with Christian Ringel, so I have to use this picture. So I would like to give a shout out to him. Without him, I don't think this paper is ready to be there, to be in, accepted or maybe in ResearchGate and so on. So I would like to thank Sigi Gudegan. I learned a lot of things from him. As well, I'd like to thank to Christian Ringel and Marco Sustad for giving me the hint in 2019 to pursue in this topic. I'm not expert. I mean, you can see that I know the stuff, but I'm not expert compared to Christian Nitzl, José Luis Roldán, or Gabi, or maybe Sigi. I learned a lot from them. So yeah, thanks to Christian and Marco for giving me a hint, direction to pursue this particular topic, and I learned a lot. And yeah, that's it. Thank you very much. And I have done my part. Yeah, I'm gonna stop share. And yeah, back to anyone who want to ask questions.
Fantastic. Yeah, on behalf of the PLS2022 conference co-chairs, Yuan Wang, you, Marco Sarstedt, and myself, I'd like to thank you very much for this impressive presentation. So our thanks goes to Christian Nitzl, José Luis Roldán, Gabi Cepeda, Junhua, Cheah, Jacky for taking the effort. And there's a lot of preparation in this presentation, a lot of time you spent for putting these slides together for us and presenting this now for almost 2 hours. That was really impressive, and I learned a lot today, and I'm very much looking forward what else is going to happen on the topic, and certainly to see your presentations at the PLS2022 conference in Beijing, October 2022. So thank you very much for doing this. And what I do now is I stop the recording at this stage and open the floor for questions.